So the second model that we're going to look at for oligopoly is the Bertrand model, which was developed, almost 50 years after Cournot. And Bertrand's main criticism of Cournot was that he says, well, firms don't choose output, they choose price. And Fisher said, yeah, that price is a more normal choice variable. And so we're going to try to keep everything the same when we compare Cournot and Bertrand, but what we're going to see is that it leads to very different conclusions, right? So we still have a duopoly. We've got two firms. We're going to have symmetric costs, homogeneous goods. Our inverse demand function is P equals A minus BQ, but since we're interested in price, we use the regular demand function. So we solve for Q, or Q equals A minus P over B. Now, the problem with the Bertrand model, as we'll see, is that we can't solve it in the same way, but we still want to think of it as, a game and find the Nash equilibrium. And in some ways, actually, because we can't use calculus, it's going to be easier to find. So we have two firms, firm one and firm two, and each firm is going to choose price, and their payoffs are profits. And so profit is, again, just going to be total revenue minus total costs, or PQ minus CQ. And information is complete, so I know what you know, and you know what I know, and we all know what the profits are going to be. So, as I said, we can't use calculus because each firm's demand is discontinuous, and this really flows from the idea that we have products that are homogeneous and consumers that always know the two prices. So if I'm choosing between two identical products and one is cheaper than the other, I'm going to buy the cheaper one, right? Because they're identical. So that means that if our prices are the same, we're going to split the market. But if my price is higher than yours, you're going to take the entire market. And if my price is lower than yours, I'm going to take the entire market. And so our demand is discontinuous. It's zero if our price is too high. It is A minus P over 2B, which is just half of the demand if our prices are the same. And it's A minus P over B if my price is lower than your price. So we can graph that, right? We can see this discontinuity where demand is zero until I get to your price, and then I have a downward sloping demand curve. And so our profit, is going to be, increasing. It's a normal profit until I get to your price, and then everybody buys from you if I have a higher price, and so I have no profit. So this is a complication in terms of the calculus. You can't take the derivative of a discontinuous function, but it actually makes, in some ways, the game a little bit easier to solve. So what we're going to do is say, all right, well, what's the definition of a Nash equilibrium? And Nash equilibrium is where players have no incentive to deviate. So in this game, what the Nash equilibrium is going to be is that my price equals your price, and it's equal to the marginal cost, as long, of course, as the cost is less than A. If it's too high, then neither of us is going to compete. So let's just imagine that our costs are $5 per unit, and you set a price equal to $9. And I'm like, all right, well, if you set a price equal to $9, then I'm going to set a price equal to $8.99 and take the entire market. And then you're like, all right, well, I'm going to set a price equal to $8.98 and take the entire market. And the price is going to go down, right? This is going to be price undercutting until we get to marginal cost, right? Until we get to that $5. Now our profits are zero. If we decrease the price, right, I could decrease it to $4.99. That's going to give me the entire market, but that doesn't do me any good because I'm losing money, right? I'm selling for less than my marginal cost. And so that would be a negative profit. And so in this case, the best we can do is to have zero profit at price equals marginal cost. So this looks a lot like perfect competition, right? Price equals marginal cost, P equals C, profits are zero, and our total quantity is the perfect competition quantity, A minus C over B. And so this is, Bertrand's criticism of Cournot is like, you have a stupid model there because, if people compete on price, there's always that incentive to undercut your competitor And we get down to the perfect competition equilibrium. And it doesn't matter whether we have 2 firms or 3 firms or 4 firms or 10 firms. As long as we have more than one, we get to that perfect competition equilibrium. And so this is generally called the Bertrand paradox. And it's a paradox both from sort of the firm's perspective, where you don't want to keep undercutting prices because you'll end up with zero profit, but also because it's not really consistent with reality, right? As we go into the empirical data in chapter 12, we'll see that most of the time when there are only 2 firms, we don't end up with price equals marginal costs and zero profit. So, all right, let's think about what happens when one firm has a cost advantage, as we did with the Cournot model. And here we're just going to say, all right, we've got a duopoly. Firm 1 has a cost advantage over firm 2, so C1 is less than C2. And what we'll do here now is we can do that same thing, right? So if my costs are $5 and your costs are $4, we're going to keep cutting prices the same as Bertrand until we get to 5, but then you'll cut it to $4.99. I'll be like, whoops, I don't want to do that because I'll lose money. I'll drop out of the market and you'll keep that price right there, right? And so you'll price it just below whatever the higher cost is, so C2 in this case. And so one of the important things of that sort of example is that it shows how the presence of a potential entrant can reduce the price charged by a monopolist, right? So if I'm a monopolist, if I'm the only one in the market, and I could charge, $10, even though my marginal cost is $4, but I know that someone else could enter the market with a marginal cost of $5, then I'll keep my price at $4.99 to keep out that potential entrant. And so that's a big difference in compared to, say, the Cournot model or just the straight monopoly model.